So you need not use voltage division technique because you have everything in parallel. So just consider that admittance in parallel gets added. So Y naught E plus YL will come in the denominator, and V naught V out equal to the I minus YFE into Vn divided by Y naught E plus YL. So substitute this value of V out in the expression for IA. So IA will be equal to minus YFE YRE divided by Y naught E plus YL into Vn. Okay, same thing what we can do in this last circuit. If you see, I have replaced everything by Y equivalent. And write IA is equal to Y equivalent into Vn. So I can assume this entire term is going to be constant admittance term, right? So I can assume this entire term to be Y equivalent. So IA is equal to Y equivalent into V in. So Y equivalent equal to minus YFE into YRE divided by YOE plus YL. So I am combining the two equations and finding out what is the equivalence admittance Y equivalent. For a typical transistor, so YFE is going to be the forward admittance of your transistor, which is going to be very much constant, and YRE is purely capacitive. So I can assume YFE is going to be GFE real number, and YRE is going to be capacitive. Mine actually impedance is 1 by j omega. Admittance means reciprocal of that. So minus j omega into CRE. Minus j omega into C. Substitute that in the expression for Y equivalent. So YFE is a real number and YRE is capacitive. So already a minus there. Here you have minus sign. So J omega CRE GFE divided by Y naught plus YL. And Y naught is going to be YL. You know what is YL, and YL is going to be the output side load. It is going to be parallel combination of R, L, and C. And Y naught E, we have written the Taylor series expansion for Y naught E. So substitute that. So you get G naught E plus omega naught into C plus C dash COE. So you get this expression. We have substituted Y naught E from the Taylor series expansion, and YL is going to be the parallel combination of R, L, and C. So when this is the final expression after simplification, you will get J omega CRE GFE divided by G naught E plus 1 by R is the real term, minus J into this entire term is going to be the imaginary term. 1 by omega L minus omega naught into C plus C naught dash E minus omega naught into COE minus C dash OE. So when the frequency of operation is less than omega naught, so when the frequency is less than omega naught, this inductive term is dominant in the denominator and the imaginary term becomes a positive number. So when you say that omega is less than omega naught, so this inductive term is going to dominate. So I'm going to consider that as a positive. So I'm going to consider the entire terms as this real term. I'm going to consider it as A, and the entire imaginary term I'm going to consider it as capital B. So J omega CRE GFE divided by GA minus JB. Okay, GA is going to be this real term, and B is going to be the entire imaginary term in brackets. See here, that is what GA is G naught DOE plus 1 by R, and B is going to be this term. And whenever if you have a complex term in the denominator, we always multiply and divide by the conjugate. So the multiply and divide by GA plus GB on both sides. So see, I am going to multiply and divide by GA plus GB, and denominator you expand using A plus B into A minus B formula, and you can expand, simplify and split into each